Okay, in 3.1a, we're going to focus again on quadratics and specifically parabolas. So as you look at your homework assignment, you're going to have to revisit what we talked about parent functions with a quadratic function where, y equals x squared. And we talked about what can make that move left, what can make it move right, up, down, all the things we've talked about before. So the beginning of your homework is going to remind you of those things, okay? But then I want to spend most of this video on how do we complete the square and how do we find the x-intercepts of our parabolas. So we're going to start with just some review problems on completing the square. So if you feel like you got a grasp on this, feel free to pause the video and work these two examples and then see if we end up in the same place together. Okay, they will get progressively harder, but we'll just start with these two to get us going. So in example 1, if I need to complete the square, I'm going to first move my constant over. So I'm going to add 6 to both sides. And then I'm going to leave my 2x there, and I'm going to take half of my middle term and square it. So half of 2 is 1, square it, and I'm going to add 1. But what I do to that, I have to add over here. So now all of this is x plus 1 squared, and it equals 7. All right, so if you recall, how did we solve these before? We took the square root of both sides, right? So we'd say x plus 1 is equal to plus or minus the square root of 7. Subtract 1. So x is equal to negative 1 plus or minus the square root of 7. And those are our two answers for x. Okay, now as we're talking about parabolas, these are our x-intercepts. All right, so let's try this again with number 2. Again, I want to start by moving my constant over. And this one's going to be a little messier because there's a 1 in the middle, all right? So I need to cut the 1 in half and then square it. Well, 1/2 squared is 1/4, right? So I have x squared plus 1x plus 1/4 equals 7. And so what is this? Well, this is x plus 1/2 squared equals, let's do this in, so let's get a common denominator here. So if I want my common denominator to be 4, that would be 28/4 plus 1/4, right? Which then is 29. All right, so again, next step, square root of both sides. So I'm going to have x plus 1/2 equals, now think about the square root here. It's the square root of 29 over the square root of 4. Well, square root of 4 is 2. Square root of 29 is some nasty decimal, so we're going to leave it like that. So we're going to call it plus or minus square root of 29 over 2. Sorry. Okay? Now, I'm going to move that 1/2 over, so x equals negative 1/2 plus or minus the square root of 29 over 2. So you could consolidate all this and write it like this, since the denominators match. It's easy enough. Okay? So that's how you handle it if you have an odd number in the center, like such. Okay? Let's try another one. Now, these two are different. Notice what's different here. I want you to notice that the a value is not a 1. Okay? Notice that's a 2, and that's a 2. So we're going to have to do an extra step in here. But the first step is going to stay the same. We're going to first move that 3 over. So I'm going to have 2x squared plus 8x equals negative 3. Now I want to factor out my 2 because I need that a to be a 1. So I'm going to just take a 2 out, leave x squared alone. If I take that 2 out of the middle term, I'm going to have 4x equals negative 3. From here, I'm going to complete the square with what's on the inside. So I'm going to have x squared plus 4x, then like before, 4 divided by 2 is 2, squared is 4. So I have negative 3. Now when I don't just add 4 on the right, I need to take that 4 and multiply it by the 2. That gives me 8. So now I have this guy. This will be x plus 2 squared equals 5. Now I can't take the square root of the left side because that 2 is there, so I need to divide by 2 first. So I have x plus 2 squared equals 5 halves. Now I can take my square root. Okay? So I'll have x plus 2 equals plus or minus the square root of 5 halves. Right? And then I lastly need to move that 2 over. All right, so there's my 2 solutions for x. Try to pause the video and see if you can do example 4 following what we just did here. If not, check and see where you might be getting stumped. Okay, so we're going to move that 1 over. Now I'm going to factor out a 2. Now I'm going to complete that square. Okay, it's 1 times 2. I've got to add 2. So I have 2, and this is x minus 1 squared equals positive 1. Okay, got to divide through by the 2 to isolate the squared. Now I take the square root of both sides. So I'm going to have the square root of 1 over the square root of 2. What's the square root of 1 is 1 over the square root of 2. Right? So then I need to move that 1 over. So I'll have x equals 1 plus or minus 1 over the square root of 2. But hopefully you remember this. You can't leave a radical in the denominator. So we have to do what's called rationalizing it. So we multiply it by whatever that radical is. And we'll end up with the square root of 2. Square root of 2 times square root of 2 is 2. So I would need to rewrite my answer as x equals 1 plus or minus the square root of 2 over 2. Okay. This is the correct answer. If you leave it like this, that's incorrect. Okay, so make sure you rationalize it. Let me know if you have more questions about that. Now, that's completing the square. That helps us solve for x. Now, when we're thinking about quadratics and the parabola, those x values are our intercepts. Okay, so if you look at these problems today, you're going to be solving for x-intercepts, which means like you're solving for x, just the way we've been doing. Okay, they're also going to be asked to find the vertex. What you're going to be given today is in what's called general form, ax squared plus bx plus c. Tomorrow in 3.1b, we're going to talk more about standard form, but today's general form. So from general form, you can pick out the vertex if you use this guy right here. What does that mean? The vertex is the negative value of b, b is the middle coefficient, divided by 2 times whatever a is. Then the y value, that's for the x part of my vertex. For the y part of my vertex, I take f of whatever I got for x. Okay? So if I get whatever I get for x, I'm going to take that and then I plug it in to my equation to get the y value. All right, we'll walk through a few examples. Okay. So also over here, now let's try this with number 5. First it says identify the vertex and the x-intercept. So let's do vertex first. Okay, we're going to use this guy right here. So negative b over 2a. So b is a positive 2, so if I make it negative, a is a negative 1. So I have negative 2, or yeah, negative 2 over negative 2 gives me a positive 1. All right, so I know my vertex then, the x value is a 1. Now, to get the y value, I'm going to take f of 1, meaning I'm going to take my equation and plug a 1 in. Negative 1 squared plus 2 times 1 plus 5. Negative 1 is, or 1 squared is 1 times negative is negative 1. 2 times 1 is 2 plus 5 gives me a 6. All right, so my vertex is 1, 6. Now it wants me to find the x-intercepts. So this is where that whole completing the square part comes in. All right, so we're going to take our equation, start by isolating the constant. Now, although this a value over here isn't a 2, it's still a -1, and we don't want that. So we're going to factor out a -1, which changes my sign. Okay. Now we're going to complete the square, like we've been doing. Half of -2 is -1, square to get a +1. Now be careful, +1 times the -1 makes it a -1 over here. So carry that -1 down. This is going to be x minus 1 squared. And this is -6. Now I need to divide through by the -1. So I have x minus 1 squared equals 6. Now we're back to what we've done before. We take the square root of both sides. So I have x minus 1 equals positive or negative square root of 6. Add 1. So x is equal to 1 plus or minus the square root of 6. These are my two x-intercepts. So this is a two-part answer. Here's my vertex, and those are my x-intercepts. All right, so on number 6, we're going to walk through the same thing we did before, starting by finding our vertex. Okay, so we find -b over 2a. So b is -4. If I take the negative of negative, makes it positive. 2 times a makes it 8. So this is 1/2. So my x value is a 1/2. Then I find f of 1/2 by plugging it in. So 4 times 1/2 squared minus 4 times 1/2 plus 21. So let's clean this up. 4 times 1/4 minus 4 times 1/2 is 2. 21. 4 times 1/4 is 1 minus 2 plus 21 gives us 20. So the y coordinate is 20. So there's our vertex. Now we're going to complete the square to solve this for x. All right. Again, the first step is always move the constant over. And I want to factor out whatever I need to get x squared positive 1. Positive 1 x squared. So I'm going to take a 4 out, and I have x squared minus 1x equals -21. Now I need to complete the square. Well, half of 1x is 1/2. 1/2 squared, or it's -1/2 squared, you get a positive 1/4. So I'm adding a positive 1/4. So the -21 is still over here, but what I need to do over here on the right to balance is 1/4 times this 4 out here, which really is just a 1. So now I have 4 times, and this will be x minus 1/2 squared equals -20. Right, so I'm going to divide through by 4. So I have x minus 1/2 squared equals a -5. Now I can take the square root of both, and I'm going to get x minus 1/2 equals plus or minus the square root of -5 equals, move that 1/2 over, positive 1/2 plus or minus I square roots of 5, right? Now, sometimes you're going to run into the problem that says find all the real x-intercepts. This is imaginary, so this would have no solution or no x-intercepts because they're imaginary. They both contain an I. So just heads up on that. If you end up with a negative, it's not impossible, but it's not considered real. So if it says find all the real solutions, then this would have no real solution. But this doesn't specify, so I'm going to leave it there. Okay. All right, let's try one more. Feel free to pause the video, try to work it out, and see if we end up in the same place. Okay. Using our vertex formula here, -b over 2a is my x value. So let's figure this out. Here's b. So -16 over 2 times -2. So it's negative 16 over negative 4 is going to be a positive 4. So my vertex is a 4 something. Now for y, I'm going to take f of 4, plug it in. Negative 2 times 4 squared plus 16 times 4 minus 31. So 4 squared is 16. 16 times 2 is 32, but it'll be negative 32. 16 times 4 is 64 minus 31. So that's 64 minus 63, which is just 1. Okay, so vertex is 4 and 1. What could have been bad is really not that bad. Okay. Now we need to complete the square to find our x values. Again, start by moving the constant over. And then we want to get rid of whatever the coefficient of x is. We need to factor out a negative 2. So that's going to change my sign here. It's going to get plus 8x equals 31. Now let's complete the square. Half of 8 is 4. 4 squared is 16. So let's see. 16 times negative 2 is negative 32. So if we clean this up, this is going to be x plus 4 squared. This becomes negative 1. All right, divide by negative 2 on both sides. So we have x plus 4 squared equals negative divided by negative is a positive. Take the square root of both sides. Plus or minus square root of 1 over the square root of 2. Well, the square root of 1 is 1. Now we got to rationalize this. This is plus or minus square root of 2 over 2. Now, got to move that 4 over. So we have x is equal to negative 4 plus or minus square root of 2 over 2. So there's our two x-intercepts. So we have our vertex and our x-intercepts, and that's what we need to be able to solve these. All right, so have questions for me, and I'm happy to help you when we get into class.